In this video, I'm going to be going over some of the basics of exponential functions. So here's a definition of an exponential function. For any real number x, an exponential function is in this form, ab raised to the x power. Okay, so the key thing to remember about exponential functions is that the input variable or the independent variable is in the exponent. Now let's just go through this list. So a is a non-zero real number. Sometimes that's called the initial value. B is any positive real number except for 1. So b can be between 0 and 1, or it can be greater than 1, but it can't equal 1. Okay, so the domain for these functions is all real numbers. If a is positive, the range is all positive real numbers, and if a is negative, the range is all negative real numbers. We'll talk about this more in a later video, but the general graph looks like this. That is if a is greater, or I'm sorry, yeah, if a is positive. Sorry, not if a is positive. That could be a positive, but that's not necessarily what I want to say. Let's just stop right there. So that's kind of the parent function for a, b raised to the x, and we'll see more how the transformations work in a later video. And then the y-intercept is 0, comma a. So this value right here is a. And the horizontal asymptote is y equals 0. So this has a horizontal asymptote on the x-axis. All right, now let's go through how we can find the value of the equation for a function that is exponential. So this example says find an exponential function in the form a b to the x that passes through the points 0, 8, and 1, comma 6. So let me just graph that. So 0, 8, it's going to be 8 up there, and then a 1, 6. Okay, so this graph does something like this. It's going to level out at some horizontal asymptote, but we're not certain yet what that is going to look like. Here's 1, 6. And then we want to know what this point is right here, f of 4. So let's find that equation. So what I'm going to do is I'm going to take both of these points and substitute them into the form here. Okay, so x is going to be 0. So ab to the 0 is equal to 8. And then I have ab to the first is equal to 6. So we have a system of equations here, and I can do a little bit of manipulation. B to the 0 power, well, anything to the 0 power is equal to 1. So here, a is going to equal 8. So what I'm going to do is I'm going to substitute this 8 in for a right here. So 8, b to the first is just b. That's equal to 6. So b is equal to 6/8 or 3/4. So we've solved for a and b. So my function is going to be f of x is equal to 8 times 3/4 raised to the x power. Okay, so something I wanted to mention that I guess wasn't up in this initial list is that if b is between 0 and 1, this is going to be a decreasing function, much like what we had down here. So that's decreasing, and that matches what we saw right here. B is 3/4, so that's between 0 and 1. And then if b is greater than 1, that's an increasing function, and that's what we see right here. All right, let's look at another example. It says a wolf population is growing exponentially. In 2011, 129 wolves were counted. By 2013, the population had reached 236. Okay, so we have two times and the number of wolves here. So it says, write the equation representing the population n of wolves over time t. Using this model, how many wolves would be predicted to be in the population of 2015? What's the percentage change each year? Okay, so 2 questions. So we're going to treat 2011 as year 0. So I'm going to say at year 0, there were 129 wolves. And then in 2013, which is 2 years later, there were 236 wolves. So those are the 2 points we're going to use. And then we're going to find the function just like we did up in this question. Okay, so we'll say f of x is equal to ab to the x power. So I'm just going to substitute these in. I'm going to have 129 as the output is equal to ab to the 0. Remember, b to the 0 is equal to 1, so 129 is equal to a. And then f of x is equal to ab to the x. So using the other point, 236 is equal to ab squared. I'm going to substitute the a value in. 236 is equal to 129 b squared. Divide both sides by 129. So 236 over 129 is equal to b squared. And then we're going to square root both sides. So I get a b value of about 1.3526. All right, so the function we're going to say is f of x is equal to a, which is 129. The b value is 1.3526 raised to the x. All right, so there's our model. It says we want to know what's the population in 2015. So we're going to say f of, 2015 is 4 years later after our beginning time that we're using. So this will be 129 times 1.3526 raised to the 4th. And I need to get a calculator. Sorry about that. All right, so we can just type that into the calculator. So 129 times 1.3526 raised to the 4th power, and I got f of 4 is equal to 431.7847 if I round to 4 decimal points. So about 432 wolves. And then it says, what's the percentage change each year? Well, this is a good question because the percentage change just comes from this value, the b value here. So another way to think about this is 129, 1 plus 0.3526. So this amount right here corresponds to the change. And if I rewrite that as a decimal, 35.26% increase per year. If I look at this previous example, f of x was equal to 8. I'm going to rewrite that as 1 minus 1/4 raised to the x. That's how I can get 3/4. So this right here corresponds to the percent change. So as a decimal, that's 0.25, which is going to be 25% decrease per unit time. So this function is decreasing at 25% each. It's not years, but imagine it was years or minutes or something, some other unit. And then this wolf question was about a 35% increase. So in general, we could always say a 1 plus or minus r raised to the x. So that's how we can get the percentage change right here.